Srikanth's last on enterprise analytics, you must be able to connect the dots because he is going to definitely add some of the things Pradeepta would teach in this module, right? So over to all, no, over to Pradeepta, hoping that this is going to be a dialogue-based, technical come functional module where everyone would appreciate the importance of this specific module. Don't give up on this because this is not going to be very easy module, but not very difficult as well. So keep the dialogues open. Thanks, Pradeepta.
Sir, you are on mute.
Yeah, thanks, Pradeepta. I was talking all this while. Were you able to talk? Listen.
Sir, you are talking on mute.
Is it?
No, not
Okay, Pradeepta. Sorry. Pradeepta, you are on mute.
Sir, you are on mute.
Am I audible now?
Yes.
Okay. Thank you, Dr. Sinu, for the introduction. Hello, everyone. Good morning.
Good
Can
morning.
I request everyone to come online video mode?
Good morning, Pradeepta.
Good morning. What about others? Please come. Video mode, guys. Not for the entire class, at least for the introduction round.
Yes, those who are online, those who choose to remain online must come on video mode. Either you are attending fully or do not attend.
Yeah, good morning, Pradeepta sir. Good morning, Shinu ma'am. This is Kiran here from batch 07.
Right.
Thanks, Kiran. Still many are there. Karthik, please check.
Okay, so let's do a round of introduction. Okay.
Yeah, I'll go first, sir. Hi, everyone. Good morning. I really appreciate Pradeepta sir to teach us about the big data, this particular module, and given the introduction that we have had about his activity and curriculum, it looks very impressive. And I'm definitely looking forward to learn many new things, many technical things on this module. And I am working as a escalation engineer in a virtualization company called VMware, and I have about 13 years of experience in information technology field. And I have taken up MBA course in business analytics with the only intention to learn more about the deep learning, more about the machine learning and artificial intelligence. And as I said earlier, I'm definitely looking forward to learn more technical and uh, the linear stuff as far as the module is concerned. So, thank you.
Thank you. Thank you.
Yeah, myself, Srikanth. I have around 16 plus of years of experience. So mostly I currently work for Wipro from past 6 years. So I'm working in the current role, working as a individual contributor for a Nokia data build tool. It's on Python. So why I feel this is very important is like when I started applying for the jobs, right, I see like 95% of the people like the skills are PySpark and big data analytics is the requirement actually. So with that I gauge that this would be a very crucial topic or the module actually, because almost all the requirements are related to PySpark and mostly 90% at least I've seen that. So I feel it's very important.
Sure. Thank you. Pradeep?
Yeah, yeah, my name is Surendra.
Yeah.
So I work in ACI worldwide. So I have 7 years of experience. So my role is I'm on into mainframes. So we develop software to banks.
Okay. Thank you.
I can go next. My
Yes.
name is Sharon. I have close to 5 years of experience, and I work as a lead BI analyst for a company called Aptean. They mainly deal with ERP products. So, uh, yeah, I'm from BA06 batch. I think this is the last subject which we have. So,
Sure.
looking forward to that. Yeah, thank you.
Yeah. Thank you.
Hi Pradeepta, good
Hi.
morning. So hope you remember me, Pradeep here. So as a way of introduction, so I have around 7 years of experience, and I work as a technical lead for SAP Business Intelligence and front-end designing using Power BI, SAP Analytical Cloud, and all. So I work for ITC, and I am from BA06. So thank you.
Thank you. Thanks.
Pradeepta. This is Tyagarajan.
Hey.
I'm a technical consultant. I'm into programming. I work for SAP India.
Mhm.
Yeah, I'm looking forward to understand the big data analytics in this MBA course. Thank you so much.
Okay. You are on mute, I think. Muzamil, you're on mute.
Yes, I'm
Yeah.
sorry. Hi,
Yeah.
sir. My name is Muzammil, and
Hi.
I work for Autodesk. I support our cloud products. We have cloud products wherein we have this data coming in from different projects, and we make sure that the product is up and running so that there is no breakdown.
Okay. Thank you.
Hello, sir. I'm Madhikeshwar.
Hi.
I've got around 15 plus years of experience, and I'm a data architect at G Power. And my major work would be getting the data ingested into Power Data Lake and make it available for the data science team, AI team, and the reporting team. It's my day to work.
Okay. Thank you. So we are done, or anyone else is left? Okay. Fine, cool. So thank you. Thank you so much for the introductions and a little bit background about me. So my name is Pradeepta Mishra, and I have around 17 years of experience into data science and predictive analytics. And I have been in my career through various, you can see predictive analytics projects, including big data and a lot of AIML projects and products also, which I have built in last 5 to 7 years. And I do like to teach on new technology and AIML, and that's how I have been part of Reva University in terms of teaching and designing the course curriculum for MTech in AI program, as well as big data analytics, text analytics, deep learning, and natural language processing.
You didn't talk about your writing and patenting and everything else, Pradeepta.
Okay. Yeah. So as an author, so I have 5 books that I have published so far, and my latest book is into practical explainable AI using Python, which is released in December 2021. And so these books are already published in Spanish, Chinese, and one of the book is again the it's recognized as a mandatory textbooks in the University of Costa Rica, University of Pittsburgh, and also the PyTorch recipe is one of the book which I wrote, and it is part of a course curriculum in Buswell University in Illinois, University of Illinois, and 5 patents I have filed so far, and 20 more patents are in process right now. So let's see. Okay. So in this course curriculum, what we start is that why big data is a problem, and since the batch or the cohort is a mix, which is like some people there at individual contributor role, some people who are already working in data as data architect, right? So there are familiar problems. So the familiar problem here is, now let's look at as a layman. Let's think about the data pipeline. Now you are working on a product or a project or creating a feature or doing some R&D or creating some prototypes. The data you need is quite huge, right? And it resides in a cloud environment which is remote. Is it in maybe in the North America, or is it in the Japan, or maybe some of the servers in China? It can be anywhere else in the world, and that's cloud part of it. It can also be part of any enterprise which is internal to the organizations. So the problem here is, how do you migrate the data that you need to develop the prototypes, that you need to develop products or features from different remote servers or a client environment. So if it's a client environment, then probably you'll be using FTP to do the data transfer. Now, there are various challenges attached to it. One, how do you translate or how do you migrate the data from different places to your development environment, right? That is, like, it has to be, the data has to be transferred in such a way that there should not be any data loss. That's first thing. Second thing, should not be any latency. Third important thing is masking, because personalized information should not go out of the organization. And fourth thing is, after usage of data, what do you do with that? Do you really archive the data? Do you delete the data? Do you keep a copy and delete the data? So what do we do with the data, right? So these are typical questions that you would like to answer. Now, when you are on a techno-functional role, so there are two kinds of roles in big data. One execution role, one strategy role. Strategy role, if you are at a senior level, maybe having around 15 plus years of experience or maybe 12 plus years of experience, you are in a strategic role. Now here you have to design the strategy. There is terabytes of data, and you have to migrate the data, use the data, extract value from the data, and then how do you archive the data, completing the data whole life cycle of it. Right? Now, how do you ensure there is no breakage in this entire life cycle of data? Right? How do you build those kind of strategies? That's your techno-functional role. Now, coming back to execution kind of role, where as a big data engineer, what kind of pipelines you will write, what platform, where you will write, right? And what are the, like, when I get back to this pipeline concept, like, is it data reading pipeline, ML model execution pipeline, data wrangling pipeline, model deployment pipeline, model orchestration pipeline? So what are those pipelines that you are going to implement in various operations? Okay, so there is a techno-functional role who designs the strategy. There is an execution role who executes the strategy designed by the earlier person or the previous role. Now, operations wise, what are the different kinds of operations? So we heard about AI operations, ML operations, IT operations. There are three kinds of operations. AI operations, what happens? You get the data, do some analysis, build models, deploy the models, and once you deploy it, then probably you don't need the data because your model is trained and you go ahead with this. So data has to be archived and stored back to the source, or it has to be deleted, right? So that is the first outcome of, let's take AI ops. Now ML ops. ML ops is a small scale. AI ops is a large scale. Why? Because AI ops can have ML ops in it. Along with that, there are other aspects also. Okay. Now within ML ops, again, you read the data, build models, deploy models, and again, delete or archive the data that you don't need. So be it AI ops, ML ops, or IT operations, simply in IT operations also, you have to publish some BI reports or some kind of a reporting need that is there. extracting the reports out of the big data and sharing with the stakeholders. It can be simple Tableau report, click report, or any other types of reporting, or maybe Power BI. So you can use any kind of BI tools to extract the value from the big data, share the dashboards with all of the respective stakeholders, and then purge the data. You don't need the data anymore, right? So the mix of it we will be covering in this sessions. So I'll just share my screen. So let's look at what we are talking about. Let me know if you're able to see my screen.
Yeah, we can see it.
In case you have any questions, you can just interrupt me, free to interrupt and ask me questions. Okay. Just a moment. So this is how, I mean, it's a mix of both the roles. As I said earlier, there is a strategy role, big data strategy, and there is a role for execution as well. So these sessions, these 4 sessions are like not enough to cover in detail about all the big data concepts. So we'll first start with the background of a big data, when it started, how it has evolved so far, where are we currently, and what is going to the next future. Then little bit into the execution part of things, so that at least even if you are strategizing on big data, you should be aware about how the execution should happen. Or because see, you are executing or you are designing. Both of you should be knowing what exactly is supposed to be done in a big data world. Okay, so that's why the sessions are planned in such a way that first we'll have little theoretical sessions, maybe today first half. Then second half onwards, we will be doing the environment setup and all. And finally, then we'll do a hands-on part of it, like executions, right? I hope everyone is having a little bit experience around Python programming, right? Anyone new to Python programming?
Sir, we have experience. I mean, I did not know anything about Python before,
Hmm.
but after the first year and going through a few of the modules, I am a bit comfortable now, sir. We use Juniper,
Jupyter notebooks,
Jupyter notebooks, and Google Colab.
Collabs. Okay,
So little bit I'm comfortable now.
fair enough. Fair enough. And the Hadoop and the big data, anyone having experience around that? Maybe in your organizations or maybe in the course syllabus, I'm sure it has not been covered so far. But whatever the organizations, like, have you heard about big data like Hadoop and Hadoop ecosystem?
Actually, we had a bit of introduction in first year,
Hmm.
Hadoop and big data. So a bit of knowledge again, batch 07 will definitely have.
Hmm.
Sure about this.
Okay, okay, not a problem. So we'll start from there. So we'll start from the definition of a big data. So the concept of a big data is that I think when the size of data exceeds the capacity of any traditional database systems. Like, for example, let's think a very simple example of Excel. Excel can handle 10 lakh rows, right? Now, if I have to do some analysis on 20 lakh records, maybe I have to split it into 2 Excel sheets. Very simple use case. Now, 20 lakh records in an Excel sheet will hang my system. I'll not be able to do any kind of analysis. I'll not be able to put a VLOOKUP there. I'll not be able to put at least a pivot table to do some kind of analysis. Now that's big data for me when I'm analyzing it on my local machine, right? Now this definition would change if I move this 20 lakh records to a DB. Probably DB can support maybe 100 lakh records. Okay, 100 lakh records maybe DB can support, or maybe let's say 200 lakh records DB can support. But beyond that, there is a latency in DB also we can experience, right? So like this, the typical systems that we have, Excel databases, SQL databases, or maybe NoSQL databases, even NoSQL database also like MongoDB and all, where we are ingesting the data. If the data size increases, then probably we have to set the MongoDB in a cluster mode, right? Because we want to combine the computing power and processing power of different machines together, stick them or stitch them together to create a cluster environment which can take the load of processing huge amounts of data. So what is big data? The big data is any size of data that is going beyond the capacity of any kind of conventional database systems. That's the big data. So what are the attributes of it? Maybe the data size is too big to handle, right? And also data moves a little fast. Fast as in like, think about the number of UPI transactions. Do we know what is the volume of these UPI transactions per hour? Yes, today whenever we are going for breakfast and having tea also, we are just doing a QR code scan, right? We are completing the transaction. This digital payments world. So any idea about what is the total number of transactions happening in an hour?
Throughout India, sir.
I'm sorry?
Throughout India?
Yeah, of course, in India only.
Yeah, it will be in millions.
It's in billions.
I just Googled, sir. It is 45 billions.
45 billions?
Yeah.
And it is only one platform?
Not sure. It says UPI.
Yeah. See, UPI is only your Google Pay, right?
Yes, sir.
There is Pay, there is Paytm. There are some others also, right? Just think about this number per hour. Okay. Now, question here is the organization who is collecting this kind of information, these transactions, right? Now let's say there is a transaction that did not go through, which somebody is complaining. A customer is complaining that, okay, money deducted from my account, but transaction did not get completed. That's an issue, right?
Yes, sir.
So then what you have to do, you have to send this information to your database guy or the data scientist or data engineer to figure out what happened to this transaction. This is the transaction ID. Whether it is really happened or not happened. If it not happened, then try to reverse the amount. If it happened, then confirm it that yes, this did go through. This is the transaction number. You check with your merchant. Right? Simple. What is this query then? So maybe somebody is complaining, you will not resolve it right away because you have other complaints also in your queue. So what you'll do, you will just park this and probably you will do an end of day analysis. If 1 hour you are getting 45 million, now imagine 24 hours, what would be the volume of data? And when you have this much volume of data, you have to ingest a query here just to figure out what happened to this particular transaction, right? So this is a big data problem, right? It's not just about running ML algorithms. It is simply even if-else conditions. If this transaction ID is generated, then this transaction should be recorded in the database. If it's recorded, then what is the current status of it? Did it go through or it failed somewhere? If it failed somewhere, then what happened to that? Right? A very simple use case of big data. So by definition, big data is high in volume. Like this is one definition of big data, where the number of transactions or the number of entries in the database are quite big. Next is velocity. Now, to some extent, these UPI transactions also, this adheres to the velocity definition. Velocity means the speed at which the data is getting generated. It can be the number of tweets. Few years back, like 1 minute used to be 4,600 tweets per hour. Now today, if you just check, what are the total number of tweets generated per hour? Again, you can do a Google search to get this number.
So it says per hour, okay. Per day
Yes.
it is 2,400 per day.
2400. It should be per minute or per second.
Okay, so the Twitter is actually trying to limit
No, no.
3,50,000 per minute.
3,50,000. Yes.
Correct. 3,50,000 per minute, huh?
Per minute, sir.
Per minute, right? And it used to be 4,600.
500 million per day. 500 million per day.
500 million per day. Now just think about this velocity. Okay. So velocity means the speed at which the data is getting generated and it is continuously moving. The clock is moving here and every day it is increasing. Similarly, look at the Instagram reels. When Instagram started, the reels were like in hundreds. Now today, just think how many reels are getting uploaded per day. Right? So by definition, again, velocity means the speed at which the data is getting generated. The third definition is variety. Variety means you have text, image, video, GIFs, okay, audio. These are different file formats through which, like, you can expect the volume of data to grow. Now just think, I mean, see, everywhere there is analytics needs. I'll explain how. So let's take Instagram Reels, right? So Instagram, like everybody is taking their Reels videos and they're uploading it. Short videos, they're uploading it. Now somehow there is a chances of getting a reel abused also. And there is a complaint. And you have to again investigate what happened to that. Maybe somebody has copied somebody's and did some kind of like alterations to the original video and posted it. You have to identify the anomalous reels also. If somebody has really done some kind of tampering with the video, right? So analytics need is there here to identify anomalous reels, to investigate and figure out any kind of complaints that happens, right? So there is always an analytics need. So now this is on the Instagram reels. Similarly, images, videos, images, there is a like anybody can crop and create a false news or fake news. So how do you control the fake news? Right? So these are some of the use cases where all three things are combined together. Variety of information is involved, velocity at which the data is getting generated is involved, and it finally contributes to huge amounts of data in the database. That is why, since these three things are happening at the same time, we cannot process it using traditional technologies or traditional way of handling data is not applicable in these scenarios. That is why it's very, very important to identify innovative ways of processing this kind of data, to identify and make decisions, and also to gain additional insights from the data. That's why when you set up your big data project, or when you are initializing your big data project, what exactly you want to do, what outcome you want to get, you have to define the outcome. Now, these small examples, when we talk about either Instagram Reels or maybe the payments, conflict in the payments processing. So what is the outcome of it? So outcome is pretty clear here, right? Now here, the project aim is any kind of complaint that comes from people, we need to first identify the validity of the problem, investigate it, then finally publish the outcome. Now that's the end goal of this big data project, right? Similarly, you can set up different kinds of big data projects as well. Okay, now the definition of outcome is what are the key takeaways? What benefit I will get? Otherwise, there is no point in doing this kind of analysis, right? So outcome of the big data project need to be defined first. Then what are the typical insights that you want to get? Insights as in the questions to the questions that you would like to answer to the data, right? So maybe take examples of, let's take e-commerce or maybe the retail stores. You would be wondering, so suppose let's take I'm going to a retail mall, I'll be wondering like what are the top 5 products sold in this mall? What are the like favorite or popular SKUs? Is it like this mall is popular for electronics? Is it popular for fashion? Is it popular for, let's take clothing and something or footwear? So what this mall is popular for? If that's the question, then probably you have to collect 1 year of data, look at the customers, what they are purchasing, what is the ticket size, which product they are buying, which segment it belongs to, create some reports, then you'll get to this answer that which are the typical products people are buying and whether it is popular or not, right? Now this is a big data project because every day imagine like 100K people are visiting your mall and maybe 50% of them they're buying something or the other, right? And if you collect this information for a whole year, 365 days, so your data turns out to be huge. Now that becomes a big data project for you. Okay. Now, even after designing this, so you design the big data project, you define the outcome, you define the questions that need to be answered, then you need to have policies around data usage. Okay. Now, what is data usage? See, every organization, they have a master data. This master data is connected to various applications, the production data. So they call it master data or production data. The production data is actually feeding to various applications, dashboards, web apps that various stakeholders within the organization, they are using it, right? Now, if you want to do some kind of analysis on the data, on the master data, it is not allowed because there would be interruptions. So ideally, you should to take a copy of the data to do some analysis. When you take a copy of the data, now that's against the data policy violation. Now, if you are taking a copy of the data, establish the purpose, which is the outcome, establish the reasons why, what kind of analysis you want to do. So mention the questions, talk to the stakeholders, take a permission for, let's say, XYZ months, because permission cannot be granted for a copy of the data for a longer period of time. You have to just take permissions for a couple of months, take the data, and using the data, you build some kind of pipelines. And if it works, then you bring those pipelines to the production environment, create more additional insights or applications and connect it to various applications. Once it is done, then what do you do with the data? Whether you want to keep it or delete it. Of course, we have to destroy it or delete it. So delete the data and post implementation of the pipelines into your existing applications, measure the value. So the questions that you are getting or the questions that you are asking to the big data manager or a big data project lead, are you getting the real value of it? Right? Now, these are 4 things which is important. And first 2 things are before execution of the project. Next 2 things are while doing execution. And the last 2 points are basically the know-how part of it, like how to execute part of it. You need key resources. Who are the key resources? People, tools, softwares. These are the 3 things that you would need, right? People, what kind of people you need? You need Hadoop engineers, Spark engineers, database guys, probably data scientists, BI developers, or some kind of IT or DevOps support. So all those people you need to identify, define their roles as part of the big data project. And finally, after execution of the project, then visualize the results. Whatever pipelines you are going to deploy or implement into the product, visualize the results, which means some kind of graphical way of representing the value to the organization. Is it clear? Any questions around this?
No, sir.
No.
No, sir.
Okay, because this is important. First, we need to understand why big data. We know there are like definition wise, there is humongous amount of data, variety, velocity, and volume. By looking at all three aspects, huge data. So the idea here is why big data? Okay. Now next thing is who needs big data and for what reason? If somebody wants the big data, then for what reason? Now, these are some of the typical questions. It's like you are a manager. Now you have been asked to develop a big data program. Okay. Now first time, so sometimes like leaders, they push different managers into different other domains just to understand their flexibility, their capability to handle new things, because they wanted to judge people. Are they like they want to push them beyond the comfort zone just to understand are they capable of handling other things also. So you are a manager, newly your boss has asked you to develop a big data program because the organization has started collecting humongous amount of data and you need to develop a strategy around it. So how this program would look like? What are the contours of it? How do we start? Right? Next, you are a manager. Now you have been asked to take over a big data application, right? Which is already in place, working in some conditions, having some issues. Now you have to figure out the issues and resolve it. Okay. You are a manager. Now you have been asked to take over a successful big data program. Your previous manager has already run a big data program. It is very much successful within the organization. He has already set high standards. Now, what do you do with that? You have been asked to take over. Right? There is nothing to define. Things are working absolutely fine. It's a very popular program. Now, what do? You say, okay, it is successful, but I will give you 2x successful. I'll make it 2x successful. But that's a too high claim, right? So then what do? Will you say, no, I don't want to take this project? You have to do something, right? Fine. Next, you are a senior business executive who wants to explore the value that big data can add to the organization. Now, senior business executive, let's take CTOs or CIOs. What you want to explore is that there is huge amount of data, but what value we can add to the organization? Can we do something on this? And this happens typically big enterprises. They collect huge amounts of data, but they do nothing. They store it is as it is. They're only spending on the storage cost of big data. There is a very good design. Data is stored in a proper way. But what to extract? What value to extract? Right? So this is a challenge. Similarly, if you are a business member or business executive, you would want to get more insights. You'd want to know new functions. You'd want to know new things that we can do using big data. Right? Similarly, database or software engineer. Now you are being currently promoted to a technical manager and you have been assigned as a big data program manager. because the background that you have hold a database or software engineering experience at your hand, you're in a comfortable position to run the big data program. Now here, how to design the strategy, you will be a little bit biased towards your database concepts. You will be a little bit biased towards your software engineering concepts. Now, does these concepts or the baggage of information that you have, it will augment you to form a big data program, or it will create bottlenecks in the process? How do you manage this? Right? Similarly, moving software engineers to managers, handling the programs, it is also challenging because software engineers, they're designed to work on certain things and they are being mentored. Now, when somebody is being placed as a manager of any big data program, now he has to take the decisions. Now he is no more getting suggestions from anyone. He has to mentor people. He has to direct the software engineers to perform some activities in the big data program. So like this, there are different kinds of roles. There are analysts, there are business analysts, senior managers, middle managers, and each and every person, if they are somehow getting into the big data way of processing, be it designing the program, managing the program, crafting and architecting the whole program, running the applications, so all those things. Now you need to understand the big data concepts, how it works, and its applications. Clear? Any questions around this?
No, sir.
Cool. Now, some of the problems that I have outlined over here, okay, just spend 5 to 10 minutes on these problems. Because sometimes, and typically my way of teaching is that, like, what is the problem that we want to solve? What are the typical kinds of problems that we may get when you are getting into a big data project, right? So first, I would like to mention the problems just to provoke the thought process around this. Okay, you have to think problems. Sometimes we don't really know the use cases. Sometimes we simply think about, okay, we'll do big data, we'll learn Hadoop, Spark, etc. See, Hadoop, Spark, these are tools. Tools you can learn anytime, right? Now, how to apply the tool to solve a problem, that is something which we need a thinking, right? So placing the tool at a right place and applying the tool in a right way, that gives you value. That is why it's very, very important to understand the typical problems that we get around big data. Okay, these are a couple of sample problem statements given by clients. Now, these one-liner statements you will get as a problem statement. Now you will be given, okay, let's take, this is a problem statement, and you go ahead and show me your plan. And when you search on Google, you will not get those things. I mean, the problems you may get, but the planning, the designing of the entire program, you will not get it. Where you will get it, probably if some of your peers and friends, they have worked on this area, probably you can talk to them and get some template, kind of Excel template or something to design this kind of programs, right? So the best way is think about this problem, understand the tooling aspect of it, and then think applications. How can we apply these tools and the knowledge that we are going to get to solve this kind of problems? Okay. If you need clarity on any of the problems, let me know. Just carefully read those problems. And if you have any questions, let me know. I'll just take a pause for 5 to 10 minutes.
Hello, Pradeepta.
Sorry, can you please repeat?
Yeah, Pradeepta. Hi, am I audible?
Yes.
Yeah, I just wanted to check, like, you have mentioned these problems on your screen. So how do you, how do we know that these problems qualify for the big data and cannot be solved using machine learning? I mean, the normal machine learning.
See, okay. Machine learning you can use to make predictions. You can use to do segmentations. You can use to perform some activities or tasks. And big data is not different from machine learning. You can do machine learning using big data as well.
Yes, I understand, but I mean, so what it says that these are the typical problems that involves big data, right? So why can't we use the normal tools, right, and not the big data for solving these problems? I mean, how do we qualify that these problems belong to big data?
Give me one example. Which one are you referring to? One bullet point.
Like, reduce customer churn by 2%. This is just an example.
Reduce customer churn by 2% in 2 months by improving customer satisfaction. Now you need to develop a churn model, right?
Yeah.
The churn model you will be using, what is the data length you will be using for churn modeling? You will take last 2 months data, 24 months data.
Probably a couple of years or
5 years?
Could be, yeah.
5 years, okay. Now 5 years data when you take for churn modeling, you'll be probably doing some kind of classification models.
Right.
Last 5 years data, like for Airtel, let's look at in a Indian scenario. What would be the volume of data?
Yeah, that would be high.
Then how do we run a machine learning model there? Right?
Yeah.
So to run the machine learning model, simple use case, you have 20,000 records, you can just upload the CSV file, Excel file to Jupyter Notebook, then run some scikit-learn models and get the model and then do predictions. Simple. When that 20,000 becomes 20 million records, what happens? Can you run a scikit-learn? Can you run a scikit-learn?
Yeah, I mean, it's going to be tough actually for the algorithm. So in that case, for all the problems, I would suggest, and like, the usual industry problems, then it will fall under big data only, right? Because the volume of data will always be high.
Right, exactly. So there are strategies around it. So always, if you just look at all the business problems, it will somehow turns out to be a big data problem, but not always, right? I'll take the same customer churn example here.
Okay.
Why do you take 5 years of data to build a customer churn model? Why not 1 year of data?
No. So if we are taking 5 years of data, then we know, like, the data is more, right? So we get to know during this period, like how many customers are churning as compared to 1 year of data.
See, customer churn is also associated with competition. 5 years back, who were the competitors? Today, who are the competitors? Right? If you have a competition today, your churn would be more. It's not driven by behaviors, it's driven by competition. Right?
Yeah.
So every year or so there is a life cycle to the behavioral changes in the data. Okay, so if we include the whole historical data, sometimes the interpretations could be a little misleading. Now we have to put a logical break there. Somewhere we have to put a logical break where there is a trend break happening. and you have to include only the recent past data to make predictions. You should not take the whole historical data. Right now, even the last 1 year or 2 years data, if you are including, if that turns out to be huge, then that's a big data problem. Okay, another example, let's take retail. If I'm buying a pair of jeans today, the average prices for a decent pair of jeans today is around 5K.
Yeah.
5 years back, it was 5 years back, it used to be around $1,000 or 1,200. Right? Same thing for even simple, let's take a jacket or a t-shirt. If you just look at their pricing today versus 5 years back, there is a huge delta. The price has increased multifold, like at least fivefold for all the products. Now the pricing strategy for this particular product today, let's take a jeans or a t-shirt or a jacket. The pricing strategy that I'm framing now, it should take into consideration the recent data, not the historical data for 5 years.
Right.
Right? So like that, all of the problems, we have to qualify the problem to be a big data problem. So before doing this kind of analysis, like let's take, I said competitions. Now in customer churn, when somebody is just, what is churn? Churn is basically when somebody is stop using your connection, right? Or stop recharging the number. That's the churn. Now, do we really know where this person is going? Yes, we have the MNP and we know that somebody is moving from this to this containing the same number, just changing the providers, right? So we would be definitely knowing where the person is going. 5 years back, you want to see people have moved from, let's take Airtel to Vodafone, Vodafone to Idea to Reliance. So these were mostly, or maybe some few more providers were there, like 5, 6 providers were there. Now today we have predominantly two competition only to Airtel. Vodafone Idea merged and then Jio. 3 major players, right? So how do you analyze this data to cut the data that can be used for big data? You have to take the whole data into some environment to apply those filters to do this kind of basic data analysis to figure out what is the right data that I should be taking for modeling. Now think if last 5 years or 7 years data, if I have to load it to one particular system to do this analysis to take a decision how much data I can take to build models, that's also a big data problem, right?
Yeah.
Because if I can't load the data, then how do I read what is there? How do I apply a filter there? How do I make a selection of the columns there? How do I do data cleanup there? Right?
Right.
So that is why it's a big data problem.
Okay. Thanks.
Okay.
Yeah,
Like, yeah.
0.6. Bullet point 6.
0.6. That sub-second website response time?
Yeah.
Yeah, go ahead, tell me your question.
Yeah, I didn't understand what is the sub-second means website. Like, is it like a testing website? I didn't understand that line.
Okay. So any website, when you are logging in, you should be able to see the contents, whether it is selling products or services or something, you should be able to see the contents. If there is a lag, right, because server is not getting connected or second attempt it is getting connected or is a break somewhere, or maybe the load the application is requesting is quite huge, right? So there can be different things here. So the response time, if it is more, then people will not use the website, right?
Yeah.
Take simple e-commerce websites. You're searching for a product, instantly it should come. If it takes time, just circle, 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 moves, probably nobody will go there once again. So how do you improve the response time there? For that, you have to collect the data. You have to load the data to some system, analyze it, then only you can conclude, right?
Yeah, got it. No, I was just confused with the sub-second there, so yeah.
Yeah. Okay, any other questions? Fine. So what are the major challenges associated with any kind of big data project? First one is capturing the data. Now this was a problem. Now today, capturing the data is not a problem. We can capture data from different sources. It's easy. The real problem is curation part of it. Data cleanup, remove redundancies from the data, remove the junk values or any kind of noise that you see in the data, curate the data for proper analysis. That takes a lot of time because of the nature of the data that is quite big. The next in post curation, you have to store it somewhere. Your storage should be decided based on, again, usage. If you are cloud agnostic, then you have to decide the uniform storage, like a single storage system where all the cloud providers, if you go in future, they should be able to connect and fetch the data. If you have a preference for one particular cloud provider, you can store there. If you don't have access to any kind of cloud, then you have to store it in-house. So basically you have to build your own servers. You have to develop or create your own storage units, right? Now store should be done in such a way that searching is easier. If you're storing it in some system where you can't perform a search, then that's a problem. So storage, searching, sharing the information, transferring the data to other applications or other database systems, like whether it is lower environment or a higher environment, any kind of transfer of data, it should be seamless, smooth, without creating any bottlenecks in the system. Analysis, of course, analysis depends on the front ending. If the front ending is a Jupyter notebook, you should be able to read the data and analyze. Front ending is, let's take Tableau or a Power BI or Click, then you should be able to read it and analyze it. And finally, presentation. The presentation, you can create dynamic dashboards using the dashboarding tools. You can use the existing libraries in a big data compatible language, and you can showcase the graphical way of representing the big data. So these are the typical challenges in big data. Now, I'll come back to now third point, that is storage. So the storage should be in a distributed fashion. What is distributed? Single machine, it has a limit to it. So the data storage system or the storage unit should be designed in such a way that we can store large volumes of data across multiple devices, right? So if you are on a particular cloud, today it is quite easy. You can just create a cluster and start storing the data. As a user, you are not feeling the pain of designing what need to be stored on which device when you are working on a cluster. Let's take you are working on a 3-node cluster. Cluster means there is a master node and there are 2 worker nodes. So it's a 3-node cluster. And if you are working on a 5-node cluster, you have 4 worker nodes and one master node. So those 5 devices or 5 machines are connected through a cluster. If you want to load a data to the master, right, for a user, there is no difference. However, the data is getting replicated, the data is getting distributed across all 4 worker nodes. And it is done internally in such a way that when you are writing a query, those data can be combined or retrieved together from all 4 machines and shown it to the user. So what is distributed file system? Distributed file system is distributing the data among various machines, computers, and distributing the data in a such a way that you can again retrieve it, query it, and use it for subsequent processes. Coming back to other concept associated with it, structured versus unstructured data. Structured, tabular data. Any kind of structured data has a schema attached to it. Unstructured, these are free flow messages. Could be text, image, video, audio, GIFs, right? Unstructured because there is no design or there is no schema attached to it. It is free flow. Now coming back to NoSQL. NoSQL is a concept associated with key and value pair, which means there is no formal schema attached to the NoSQL database. If it's a SQL database, there is a structure or schema attached to it. If it's a NoSQL database, you can design a JSON and ingest the JSON. Okay, so the data storage and retrieval becomes very easier when you do not have any designed schema for it. So it's quite flexible to handle large data. So if your data has a structure like key and a value pair, and you can ingest it to a NoSQL database like MongoDB or Cassandra, and you can read the data using NoSQL query languages. Okay. Now comes the concept of a Hadoop. The DFS, or the distributed file system that we spoke about. The Hadoop is a tool, or you can call it as an open source framework. So initially it was invented as a tool, which should be able to handle multiple machines together and create a cluster out of it. And you can perform various activities on the cluster itself rather than on a single machine. So this Hadoop ecosystem or Hadoop framework, it allows us to store large amounts of data, write query to process large amounts of data, right? And it is designed to scale up. So maybe you are using single servers, you can scale it up to multiple servers or maybe thousands of machines. So Hadoop is nothing but it's a distributed storage computing framework. But now when I say computing, Hadoop doesn't do any kind of computing on its own. Hadoop enables other tools to perform computations. Hadoop is only a storage layer. It enables the computing layer. Hadoop doesn't have its own computing layer. Okay. MapReduce is the program which we can write to get the data from a distributed file system. So MapReduce is an algorithm. You can call it, some people they call it a software framework, but some people they call it MapReduce as an algorithm, which is typically used to fetch the key value pairs of data which is stored in a distributed file system. Okay. The objective of a map task is take an input, assign some numbers to it, and just do a mapping. The reduce task is to perform a function and generate an output. The function is an activity. The map can be, let's take word count. You assign one number to each of the tokens or each of its. The reduce task is you want to combine and say how many words are there. You want to combine all the text and want to understand what is the frequency of each of the words. present in the sentence. If it is any of these tasks, then the reduce task would be apply a sum function, where is summing up the numbers and publishing the count. So the map task is to assign a number or assigning any identifier as key and a value to the incoming data or input data. The objective of a reduce task is perform the action that is either sum or average or count on the mapped data and publish the output. So that's the role of map and reduce task. Any questions so far before we get into other concepts associated with big data?
Yeah, the map reduce, will it use, it will be used for both SQL and NoSQL, right? When you write queries to get the data actually.
Map reduce to SQL and NoSQL.
Yeah. It is agnostic, right? Like basically.
NoSQL, you don't need map reduce, right?
Okay.
SQL, you need map reduce, but explicitly we are not doing map reduce. Map reduce is happening behind the scene.
Okay. It's a wrapper sort of.
Yeah. Any other questions? Let's go to other concepts associated with big data, because these terminologies we'll be hearing very frequently. What's a job? Job means any task that we want to perform, and job is a combination of various tasks. So suppose our job is to read the text file which is there in a folder on my machine and count how many lines or how many words are present in that text file. I just have to output a number. So let's take, I have taken an article, stored it as a article.txt. I just wanted to understand how many words are there in that particular text document. That's a job. So job means a small script which reads the input, and the input has to be in HDFS or local machine somewhere. If the input is stored somewhere, it performs the computations on the data, which is taking the count of number of words and just prints the number, that is the output, which means how many words are there in this text. Now this job has certain stages to it. So stages means there is a specific map function and reduce function which is attached to it. So the stages are defined automatically based on the activities that you want to trigger. Okay, so stages we are not defining manually. Stages are auto-defined. Now, how it is designed? This is basically designed based on the computational boundaries. Okay, simple example. The same article.txt. There are, let's take 1500 words in that document. All 1500 are unique words. Some of the words are repeated. For example, this, a, these are stop words, and these are repeated probably many times in any kind of sentences, right? So what it does in the stages, first it assigns a default number to each of the keywords. That is the mapping step. After this map step, before going to reduce step, there is something called shuffling step. The shuffling step, basically what it does, similar strings should be put together similarly, which means the words like, let's take this, there, here, which, a, code, and data, etc. If data is repeated 20 times, all those data strings should come together. Like that, the mapping, after the mapping step, there is a shuffling step, which keeps all the similar strings together with their numbers. Then reduce step applies. Reduce step just sums up the values corresponding to each of the keys. Now, sir, let's take look at data one, data one, data one. Now, what it does, reduce step, simply it sums up the three numbers 1, 2, 3. It stores data equal to 3, which means data word is present 3 times. Right? So the stages are quite defined based on the computational boundaries, and task is each stage has one task. The first stage is mapping, task is done. Second task is partition, partition done. Third task is shuffle, shuffling is done. Fourth step is summing up, applying a function, job is done, right? So job, stages, tasks. Each stage, some task is performed. All tasks combined together, that becomes a job. Okay. Any questions on these three things?
Yeah.
Job.
Yeah.
Yeah.
In the stages, right? You mentioned about shuffling. When you in the shuffling, if I understand, like you group all the words with the same count, actually, right?
Not same count. It is like same words with count.
Same words with count. Okay.
Right. Let's take the words present in this slide itself. So if I just take code is here, then code is somewhere else also there. Now let's take even a machine. Machine is here, machine is here, machine is there somewhere also, right? So all the similar words as having a number from the map stage should be grouped together. That's the thing.
Okay.
Okay. Any questions? Now, let's go back to the DAG. The DAG stands for Directed Acyclic Graph. What does this mean? DAG is basically a combination of various operations that you are doing as a job. So the job is converted to a DAG. Now, if you are reading an input file from HDFS, performing the word count, and you're printing the number of words or the count of words present in that text file, this becomes a job. Now, this becomes a generic job, right? Today it reads the file that you are storing. Tomorrow you can pass this program to your colleagues. They can also read from the same input or a different input. Your input can change, right? However, the program will not change. The program name is word count. So what essentially you can do is, if the job is generic, based on the any kind of input, if you change the input, the program still remains same. Now, actually, you can convert the job into a DAG. Now, this DAG becomes like a function. Now, this DAG you can call from any orchestration layer. DAG you can ingest from any kind of like DAG platforms, right? So you can pass this DAG also to anyone else so that they don't have to write this whole program on their own from the beginning, right? I'll show you how it looks like, how the DAG looks like, and what are the typical DAG operators. I mean, once we see the result, we'll see how it works. Okay. Then comes the other three concepts. Executor. So the executor is nothing but it's a specific type of machine which is responsible for executing a particular task. And there are two core components of master and slave. Master computer is the machine which runs the driver program, which the driver program runs. Okay, so it can be a bigger machine. Let's take 32 vCPU or 12 core machine or higher configuration machine you can choose as the machine on which the driver program runs. Now, executors, they are supposed to run on a slave machine or a worker node. The slave machines or worker nodes, we call them, are the ones on which the executor program runs. The executor program returns the results. Okay, that again gets back to the master. This master slave architecture, the master is the core, which means it controls the slaves by assigning or allocating memories, containers, applications, etc. So master is responsible for assigning a task, assigning some kind of jobs to the slave computers. The worker computers or slave computers, they execute the program and they report the results to the master computer. Typically, the master computer should be a bigger machine. The worker computers, slave computers can be many with a smaller configuration. Any questions on three?
What's the link between executor and master? Like both are that comes at the higher end actually, the executor.
Executor runs within the worker.
Oh, okay, within the slave.
Yeah.
Okay.
Okay. Now some thinking. Who would like to go first on this? Anyone would like to answer any question from this exercise? You can choose multiple questions on this, but at least you have to pick one problem or one question from this and elaborate it.
Sir, this is Kiran here. In my organization, right? Since it's support based, I believe getting the NPS, that promoter survey which you were talking about, I think that stands as the most highest priority factor in our, I mean, of course, the product, the virtualization, all those technical concepts are there, but at the end of the day, it is the customer satisfaction that everybody has their eyes on. So I think the big data, or if we try to get the factors or the parameters responsible for the customer to be satisfied, is what I would call a big challenge in our organization.
Okay.
So I think the point number 3, which says provide your own definition of what big data means to your organization, I would say getting the case numbers and the customers satisfaction survey out of all the millions of cases that we have in our database. I know that there might be a team dedicated to that, but from the standpoint where I am, I think that's the data issue in our organizations.
Okay. Thank you.
You're welcome, sir.
What about others? Please go ahead.
Yeah, in the same context, like Kiran explained, like we have the Jira, right? We have historic data, so we can analyze the data and classify the problems actually to which bucket it falls actually.
Okay.
So where I work, where I support a cloud product, we have big data wherein the data comes from different IoT sensors that is in construction industry, like equipped on machines to provide information of active and ideal time and geolocation data of the machines, as well as the weather and traffic data for a project. So there will be many construction projects in a hub, and all these projects are organized in a way that the manpower is not underutilized, and also the traffic conditions, like whether it is good time to transport the logistics. I mean, we have certain rules, right? Like we should not be transporting the construction material in the morning. It should be done only in the later half of the day. So all that is stored in a cloud platform, and using that data, it can be analyzed and can be seen how efficiently the work can be done.
Good, very good. Okay. Days, please go ahead. Who is going to be next?
Yeah, Pradeepta. So, hi, this is Jyoti here, and I work for SAP. And SAP does have their own enterprise cloud where the systems from multiple customers are hosted on that particular cloud. And each customers will have multiple systems within their organizations. So I think that the big data comes into picture where we need to do the health monitoring of this particular customer on the proactive basis as well as on the predictive basis.
Okay.
So we have multiple customers who are hosted on HEC actually.
Health monitoring, as in like anomaly detection, or is it like regular reporting?
Yes, so it is regular reporting as well, whether when the system is going down, as well as the number of users who are performing activities on the systems, right? So it includes many KPIs as such.
Okay. Okay. Next.
It may be like we will be getting a number of transactions from ATM or POS terminals. So it may be debit, credit, so there cash withdrawal. So there are a number of transactions happens. So identifying which ATM has how many transactions, how many debits or how many credits. So out of India, it is a huge number of ATMs we have, huge number of POS terminals we have. So identifying it, even identifying a fraud transactions out of the number of transactions that we process.
Right. Okay. Thank you. Which is going to be the next?
Hi, Pradeepta. Pradeepta, I'm
Hi.
Deepak.
Hi.
Yeah, so I work in VMware and we have around 20,000 tech support engineers around the world handling customers' issues. And per engineer basically get 4 to 5 SRs in a day. So if we count that, it would be like 1 lakh SRs per day around the world. And if we take a huge data of like 3 to 4 months in order to analyze that, we probably would be needing big data analytics for that.
Great. Great. And the SRs are typically the input is coming as a text.
Yes, input is coming as a text. The description is coming as a text as well as the customer survey. It comes as in text as well as in rating form.
Okay.
So NPS is one of the parameter that we need to evaluate. Yeah.
Cool. Thank you. Next.
Hi, Pradeepta. I work in a healthcare industry. So there actually we deal with the healthcare devices like CT scan, PET scan, and the MRI scans. In these scanning machines, mainly in the CT scan machines, there are a lot of like DICOM format, the huge volume of DICOM format images are generated, where we do post-processing and create the final image for the radiologist. So this means DICOM is a similar, like one type of image format similar to JPEG and the PNG, but it is DICOM is compatible with the other devices where the hospital can store and print the images. So that is one example where we have this unstructured data and huge volume of DICOM images.
And where do we store it currently? These images?
these images actually in CT scan also there is a storage where the initial generated images are stored and also final result is stored. And again for the processing, what we do is we have our own in-premise cloud platform. There actually we it is a we have it is a, again it is a in-premise. We have a DICOM storage and services which developed means in-house. It provides all the services to store, to search, and to create the IDs, and also to read and write the images across different processing platforms. That's where we store it.
Right, but my question is like, is it like already parsed, like RGB you are storing, or you are storing the image as it is?
We are storing the images as it is. Again, those images has to be processed again.
Right. So the processed data are you storing or not?
Processed data also again we'll store it back to the CT image.
Okay.
In the CT machine. Sorry.
Okay. Okay. Yeah. Thank you. Next.
Yeah, this is
Yeah. Hi.
So let me explain the from perspective of SAP. SAP it's enterprise company. So let's take any business companies, like for example retail company. So day in and day out they create thousands of invoices. So it is a perfect example for a structured data. Need to store this in a big data, obviously. And also if you take any some chemical industries and this process oriented industries, they used to store the images of the location or the equipment or the process. So this is the example of the unstructured data. So we need to apply the big data analytics to store and retrieve and analyze these images.
Okay. See, the form data is like there is a question or there is an entity that you want the responder to fill in the information, right? So all those entities, ideally you have to scrap and you have to put it as a structured table format, and responders you can add it as a like a record to your structured table. So like a key and a value pair, you can store it and multiple records can be stored. And you can consider this as a structured table. Okay. And then you can apply big data on this, so that your search becomes easier. I'll give you one example. Let's take, there is a form. It asks for your name, email ID, mobile number, location, company, designation, and demographics, few demographics like gender, religion, race, marital status, etc. All those fields that I said, potentially it can become a column header. And your record becomes me, first person, and whatever values I have put. Let's take my name is so and so, my email ID is so and so, my mobile number is this, etc. Now, second responder it gives, it should be the second record. So essentially, you can convert the forms to a structured table, right? So your form is now no more unstructured data. You can give structure to it. And why structure? It is easier to store, easier to ask queries, retrieve information, and you can scale it up. Okay, because you are not doing a free flow text search here. Fields you can call by column header, and you can perform conditions on the records and retrieve the person's names and details. Right?
Yeah.
Okay, cool. Anyone else would like to take?
Sir, in case of forms, we should be sure that the metadata of the forms will not change for a couple of years, right? Like in case in between there is a new field added, then it would be difficult to scale up, right?
we can insert a new column there.
But for the other, I mean, for the previous values, it will
It will
be
be
null.
NA. It will be, yeah. It will be null, and same thing goes also if a field is getting discontinued in subsequent forms, that will also become null.
Okay, sir.
Fine. Now let's look at sample applications and what are the typical characteristics of it and what kind of sample data sources we would need to perform any kind of big data application development. So need a break here because it's been quite some time. Do you want to take a small break?
Sure.
Okay, fine. So let's take a break for 10-15 minutes. We'll be back by 11:15.
Sure.
Hello everyone, we can start now. Hello.
Yes, sir. Yeah.
Okay, fine. So some of the applications, like for example, like credit card fraud detection or data profiling, or maybe clustering or segmentations or performing some kind of optimizations. So there are different kinds of applications, and from the previous slide also, you guys talk about various use cases from your organizations. And what we can look at is the characteristics where there are large volumes of data. There is two kinds of throttling which would be required: data throttling, computation throttling. Okay. Maybe sample data sources, what can help us? Any kind of sensor data from smart meters, IoT devices, or network components, where the data velocity is very high. If your velocity is very high, volumes are also associated with it. Then two strategies you have to follow. We have to form, which is data throttling strategy, computation throttling strategy. Similarly, credit card fraud detection. There are two kinds of fraud. There is something like point in time or point of sales data, where immediately somebody is swiping a card, you have to perform the computations, apply the scoring model, identify whether it is a fraud, no fraud, and generate flags. That is one. There can be other kinds of need, for example, risk assessment, whether the person should be given a credit card or not. That requires customer profiles, that requires predictive model like segmentation exercises, or predicting the risk, predictive models, right? Predictive models, it requires parallelization. However, some kind of point of sales related informations or predictions on the edge of the device, it requires data throttling. Customer profiling also, sometimes it takes a lot of time to form or create those segments, and sometimes we have to do a computation throttling also, right? So net, if I just look at the unique characteristics, there are 4 or 5 things that emerges from here. One, due to volume of data and velocity of data, you have to identify the parallelization strategy, throttling strategy, and computation strategy. Clear? Any questions on this? Okay. Now, these two things we have already discussed before. That is like demonstration of the value, because whatever big data projects you are running or initializing, we have to get benefits out of it. Otherwise, there is no point. And operationalization, ongoing basis, how it is going to be sustained as an organization. Okay, so what it takes to bring in the big data to an organization? Definitely, it has a steep learning curve. Why? Multiple tools are involved in the process of big data. It is not just only Spark or Hadoop. There are so many tools in the ecosystem that you would need to learn. Okay, I'll come to those number of tools that you have to understand, learn, and why it is important. Clear? Data lifecycle changes. It keeps on changing. Sometimes, like again, with the different kinds of data, like sensitive data, PII data. So the data lifecycle requirements are also, they keep on changing over time. Infrastructure also keeps on changing. For example, few years back, AWS Redshift was used to be the database where you can run the glue queries there to extract the data from Amazon Redshift to perform any kind of learning analysis, any kind of data analysis you have to perform. You have to first write those glue queries on top of this Redshift data. And today, there is a new database which is coming up, that is Snowflake. So everywhere you can see Snowflake is there. So your existing infrastructure would change. Snowflake, you don't have to write the glue queries on top of Snowflake, right? So tools are emerging the existing infrastructure would change, and sometimes the way of a processing, storing also would change. Now with this new, like for example, we heard about data warehouse, then data lake, then data lake house, then came up this snowflake. It has snow park, right? So with time, new tools, infrastructures, ecosystems, they are emerging. So with this, how do we keep change? How do we keep pace with the change? Right? We have to also catch them, because all other tools, they will start quickly adopting the new technologies, new ecosystem, new infrastructures. And if we will not learn it, then we'll stay behind. We have to start learning those things as soon as possible. Fine. Data intent. So when I say data intent, it's about what do we want to do with the data? Is it only processing, creating some reports, generating a PDF file, sending it to respective stakeholders? Is it performing machine learning models, generating predictions? Is it about only writing the queries, doing data cleanup, maintaining sanity, or taking up the request and passing the data from one environment to other environments? What is data intent? At the same time, also size and duration. What's the size of data? How much duration it is, right? So all those things we have to keep in mind while taking into account big data in your projects in your current organization. Any questions on this? No questions? Okay, fine. Now we get the idea about big data. We get the idea about little bit about use cases, right? And then how do we implement it? What it takes to implement it? Okay. So there is a book. I hope it is there already in your LMS, which is uploaded. So recognizing the opportunity for a big data, there is a chapter 2, and I would request you to read those chapters whenever you have time after the class. Now, this would help you in identify the business challenges where big data can be used as a technique, right? So recognizing or sensing the opportunities, big data opportunities, this is important. I'm sorry, you can see my screen still, right?
Yes, sir.
Okay, briefly some interruption happened from my side. Okay, defining the expectations. The expectations would be like, is it like improving response time? Is it processing faster way? So what is the response? Okay, improving the response time. So define the expectations. What is the value improvement stakeholders are expecting from the big data project? Scope of a pilot. Now, before starting any full-fledged project, we have to run a small POC to figure out and especially specify what concepts are to be proven during the pilot. Then identify and acquire the skills necessary for big data development, which is kind of like Hadoop skill set, Spark skill set, or data engineering skill set, etc. What are the skill sets that is going to be applicable or useful in this entire development of the program? And finally, program management, development and assessment, etc., and move into production. So these are the typical stages that any big data project would go from idea to implementation. This is something which we have already discussed. What is the data veracity of it? Big data, again, some more use cases, big data use cases. And here, this is a columnar storage versus a row storage, and the slight difference here. Now here you can see this is one slide, this is other slide. So here we have these two slides. What we are talking about, this is about the row storage. Okay, I'm sorry, I'm not getting that marker somewhere. Just you can see this arrow here, right? This is a row storage, which is typical traditional database storage. We have columns, we have records or rows, and we store it this way. Okay. So one row at a time we will ingest to the database. However, in the big data world, we are storing a columnar storage, which means this is going to be the key, this is going to be the value, this is going to be the key, this is going to be the value. Like this, if I ingest a key value format like this, it's a columnar storage, right? And we have seen improvements in doing the columnar storage instead of a row storage. Okay, so row storage and columnar storage, there is always a debate and discussion happening, and some people they claim row storage is better, some people they claim column storage is better. But if you find columnar storage is better, there is a specific data type which is called a Parquet file. Parquet. It's called a Parquet files. Parquet file formats, these are basically columnar storage table structures. CSVs are like row ingestions. Parquet files are basically columnar ingestions. So when you are looking at data ingestion pipelines in a big data environment, it's better to go ahead with the columnar storage, which is efficient enough, right? And typically it follows a NoSQL format, that is key and value pair format. Okay, so this is a small difference between the way we store data in a regular traditional database system versus a columnar, like a modern way of storing the data in a big data environment. Okay, so some of the aspects we have to look at. One is access and performance, speed of performing joins and aggregations, suitability to compression, data compressions, data upload speed or loading speed. These are the 4 dimensions when we are looking at row format versus column format. We can see some differences. Now, what are those differences? Row format, which is this slide, the arrows you can see, it is going from left to right. Columnar storage, it goes from top to bottom. Okay, now here the difference. Access and performance point of view, limited in supporting many simultaneous diverse queries. However, in a columnar oriented, it is engineered to enable selective traversal of the required columns aligned along commonly used caching strategies, which increases the data access speed. So from access and performance point of view, columnar storage is better. Now coming back to joins and aggregations. So the need to stream entire records into memory to find the join attributes severely hampers the performance by adding significant average access latency. However, data access streaming along column-oriented data allows rapid join condition evaluation as well as incrementally computing the results of aggregate functions, which means multiple processing units accessing and aggregating different columns in parallel. It basically increases the overall query performance. So columnar data is better in terms of joins and aggregations. Coming back to compressions. The row-oriented data, it is difficult to apply compression in any way, which means we cannot achieve data compression. However, columnar alignment exposes opportunities for compressing the data that can result in a significant decrease in storage needs while maintaining the high performance. Again, from compression point of view, columnar storage is better. Loading speed. In a row-based arrangement, all of the data values in each row need to be stored together, right? Which means there is an inherent dependency that prevents the parallel loading, because otherwise your one key may or one record may shift to other columns. So there is a dependency on it. However, the columnar storage allows you to segregate the data based on the column, which means using key value where each column could in principle be stored separately. That means this allows the database system to load columns in parallel using various multiple threads, which means if you are designing the architecture for a big data, always make sure to follow a columnar storage rather than a row storage. If you have a small data problem, a small CSV file, it really doesn't matter whether you go with row format or a column format. However, if you are going ahead with a data ingestion of a terabytes of data, I would recommend to go ahead with a columnar format rather than a row format. Clear? This is about designing the way the data need to be stored. Okay. Now, still, there are some questions around or the use cases. So many ads. Which ones you are going to click? Almost every page you browse today has a set of advertisements displayed on it. Are these ads always relevant, or do you feel why I'm being shown this? If it's the latter, then isn't it worth it to tailoring the content of each user? Right. So there is a project on Kaggle. It's called Outbrain's Click Prediction Dataset. There is a dataset which is available on Kaggle. Right. It's basically the web's leading content discovery platform, which is trying to solve the same problem, like which user, which ads they're going to click. The objective is to improve the Outbrain's recommendation algorithm, which will mean more users, right? And more users uncover the stories, those satisfy their individual tests. Now, what is this? This is about a project. Okay, I'll show you. This is a big data project because this problem statement itself, like which advertisement the user is going to click, right? Each and every, there are 7 to 8 data sets. We have to perform joins, and each data set is of size around 2 GB. So this is a use case that I will be giving it to you at the end of the sessions. You should be able to come up with a plan to analyze this. This is a case study. Okay, so this task you have to perform. Maybe I can describe this a little bit. I will share this PPT also. I'll describe this a little bit, but this is one assignment which you take your time. We have next 4 weeks, next 3 weeks. Within next 3 weeks, you come up with a plan. How do you want to solve this problem? Data you have access to. You can just click on this link. You should be able to open one Kaggle account. I hope everyone has a Kaggle account. If you don't have Kaggle account, please open one account. Once you open this account and sign in, then click on this. Go to this project, Outbrain Click Prediction /data. You should be able to download the data, right? Now, after this, go through this problem statements. Okay. Now here, the brief is about it. Data, a sample of users' page views and clicks as observed on multiple publisher sites in US states 14th June and 28th June 2016. Now this is 14 days data, 15 days data only. Volume, including multiple data sets, over 2 billion rows, which is 100 GB of data is there uncompressed. 100 GB of data uncompressed. Okay. So you have to read this 100 GB data to perform some analysis so that you should be able to answer these questions. Clear? You are not competing with the Kaggle competitions. Accuracy doesn't matter. The idea here is you should be able to upload those 100 GB of data, or at least create a plan around it. Fair enough? Questions? Clarifications?
Should it be a plan with the execution model or just a plan?
There is no model here.
In a sense, like finally, like data should be uploaded and we need to derive the insights, right? That's the expectation.
Right. So question is here. So many ads. Which would you click? Right. The more closer you are answering this question, like you are in a better position.
Sure. Thanks.
Okay. So this slide I will share, and these two slides has the details around the project. Okay. So that's all from the theoretical aspects. Now let's go into the practical aspect of understanding big data and all. Okay. So I hope the infra part is ready, right? Do you guys follow the instructions uploaded on how to set up the environment for big data? Did you check your LMS? Yes, no. Can you check your LMS, please? There is a instruction to create, or instructions to at least get your environment ready for big data. Can you check? Can anyone please check quickly on LMS?
Sure, sir. I'm checking it.
Okay.
I think we don't have.
We don't have. Okay. Anyone from program office available on this?
Sanjay, sir.
Hi. Can you please check?
One second. So we'll just finish it and call you, sir. So it's not been marked.
Sorry.
Sir, actually, he said that it's not mapped. And usually we students are informed a day in advance if any such prerequisites are concerned regarding any setup. So maybe we'll take time to do that, sir.
We'll need time to do that. Okay. Okay, fine, fair enough. Hello, hey, Legacy. Okay, now I'll share my screen. But let's have a look. This is something which we covered right now. Okay. This is basically essentially talks about what is the big data need and reasoning behind it. Okay. So we are done with this. I'll just close the slide. Now, typically, before even moving ahead, just let me check. There is one more slide. There's one more slide. Okay. Now, this one I'm going to cover right now. What are the typical tools that would be required in a big data processing environment? Okay. The most common tools are like Hadoop and Spark. So there is little bit conceptual clarity would be required. What is Hadoop and what is Spark? Okay. So guys, if you have questions, please ask me on this. It requires clarifications or it requires clear understanding about those tools. Okay. Any questions, please ask me and try and feel free to interrupt me also. Hadoop versus Spark. Hadoop is, as I said, it's a distributed storage system. Hadoop doesn't have a computation layer. Okay. Spark is a computation engine. Spark doesn't have its own storage layers. In that case, you need combinations of both. You need combinations of a Hadoop and Spark because Spark would require a database to run. Behind the scenes, Spark requires a database, a distributed database that could support this. Right? So that is why Spark works on top of Hadoop. Hadoop is the backend for Spark. Hadoop doesn't have its own storage, computation layer. Right? It is not Hadoop versus Spark. It is Hadoop and Spark. Okay. Spark you need for computations, reporting, like any kind of a processing. Hadoop you need to store. Okay. If your data is not in distributed format, then your computation layers or the processing layers is not going to work. Is it clear?
Yes, sir.
Now coming back to languages involved in the big data process. Now, little bit background about all those languages that we can see over here. In earlier avatar of Hadoop 1.0, so Hadoop has two versions. Hadoop 1.0 there was no other tool to do computations. So there are few more tools maybe you are aware about: Pig, Hive, uh, then there are some other tools. So Pig is for data analysis on Hadoop. Hive is to run SQL queries, or it is called basically Hive queries on top of Hadoop. Now those tools are redundant in the world of Spark. Okay, but earlier used to be in Hadoop 1.0, Pig and Hive. Scoop and Flume. Scoop is for structured data. Flume is for unstructured data. If you have to ingest data to Hadoop storage, distributed storage system, you have to ingest the data. If data is structured, you have to use Scoop. If you have to ingest the data to Hadoop, data is unstructured, you have to use Flume. These were additionally two tools. Okay, so ingestion of data, you need Scoop and Flume. Further data analysis, you will be need the Pig as a tool. You want to run some SQL queries, you need a Hive on top of Hadoop. There are four tools here, right? So 2.0, it said you don't have to use all those tools in a Hadoop ecosystem. Hadoop has to be compatible with all the popular programming frameworks. Okay, Hadoop understands only like it's a process, it's a storage layer. It's not a computation layer or processing layer, right? So on top of Hadoop, Spark came into picture. And before Spark, there is another tool. It was called Mahout, Mahout. Mahout is now deprecated. It's no more in production. Okay. Mahout was a MapReduce program. It's a tool that was supporting MapReduce that used to work on top of Hadoop. Now later on, Mahout became redundant, and once it became deprecated, then Apache Foundation, they came up with Spark, another tool, right? So Spark became very popular because it's quite flexible. The language to write programs in Spark is called Scala. Okay. The language that Hadoop understands is Java, right? As a data scientist, you will be using either Python or R. Now look at the confusion over here. Spark understands the Scala. Hadoop is compatible with Java. Data scientists, they are comfortable with Python and R. So what do you need? You need to make wrappers to let the Java developers write their Java programs to do something. It should talk to Scala function. The Scala function should execute it on top of Hadoop. One, you need to write wrapper functions. Scala programmers, they have to write the wrapper. The function internally calls the Java process. The Java works on top of Hadoop. Second, third, you create a wrapper around Python. The data scientist uses a Python API. The Python API calls internally Scala. Scala works in Spark. Spark works on top of Hadoop. Similarly, you write a wrapper around R, create an API. The data scientist should be using R as a tool. This R program should call internally Scala. Scala works in Spark. Spark works on top of Hadoop. Is it clear now?
Yes.
Yeah. Yes.
Any questions? Now, I think many of you are already familiar about Java. Anyone knows Scala programming?
No, sir.
Okay. Anyone knows R? Python? Python I know. R?
Basic.
Okay. So these are the languages that we need to know. But again, as a data scientist or a business user or a maybe like a manager, is it possible to learn 1, 2, 3, 4 languages? No. The language should be uniform. So if a data scientist is comfortable in Python and R, let them write the Python and R programs. Spark should be doing internally mapping and run it on top of Hadoop. Right? That should be the case. Okay, so this concept wise, we know that what is Hadoop. Now coming back to the architecture for this. So Hadoop has 3 important components. Distributed computation using MapReduce, distributed storage using SDFS. There is a YAN framework. YAN stands for Yet Another Resource Negotiator. So what it typically does is when a worker node, so basically the master node gets a job request, the job request is broken into logical stages. Each stage is performing a particular task. For performing a task, you need computation, and for computation, you need resources. So for performing the computation, how many worker nodes you have to invoke to perform that kind of computation, right? So there is a resource negotiation that happens between master and worker nodes. Then worker nodes has been assigned some specific memories or processing powers. Each worker node will have its containers, app master, and so let's not get into the technicalities of how exactly the master slave architecture works. We just have to know that there is a YAN system which manages the whole resource negotiation process of churning up the containers and application master and application placeholders to perform the computations. And there is a common utilities service, which is basically like churning up a cluster, shutting down a node. So all those are restarting a node, all those activities can be performed using common utilities. Okay. This MapReduce is originally written in Java. And this is not scalable. And it's not only going to be scalable, it should have a universal application. And today you are writing a logistic regression model. Tomorrow you are writing a decision tree or a gradient boosting model. The MapReduce program should be flexible enough to extend it to other algorithms. That's how you can perform distributed computation. So it has its own limitations. The entire MapReduce program you have to re-engineer and rewrite from the very beginning. Okay. That's why it became a bottleneck in Hadoop. That is why Spark came into picture. Okay. Only Hadoop storage, distributed storage is something which is powerful enough to take it ahead. Now the scalability of the Hadoop distributed storage system, there are 2 kinds of scalability we can achieve: vertical scalability and horizontal scalability. Horizontal scalability is about adding more processors or more machines into the cluster, create a larger cluster of it. Scale up or vertical scalability is basically same machine, increasing or reconfiguring the machine size based on the size. Scale out means horizontal scalability. Okay. Now, as we know, the MapReduce is helping us in performing the distributed computation. But this is one example of a MapReduce. Okay. There is a sentence and we have to do a word count. Which word? What is the total number of times it is present in the corpus? Corpus is nothing but a collection of sentences. let's take this is a corpus. It has 4 sentences, first, second, third, and fourth. 4 sentences are there. Now at the mapping layer, what happens? Each word will be broken from the sentences and each word will be assigned a default value. Now default value is 1 to each of the words. Now what happens? A shuffling. Now here the map is parallel. The map function of breaking the sentence and assigning a value to it, it is independent. This task is independent of this. This is not getting processed sequentially. It's in parallel, right? So if you have 20,000 sentences, so 20,000 map functions can be triggered at once. So this will create this kind of a view. Then comes the shuffle stage. So shuffling stage, even before reduce step, there is a shuffle step, which what it does, it collects the words like, let's take pick one here, and pick one here. The pick word is present in 4 different sentences. Let's bring this word together. Now this happens here. And then the reduce step happens. So the shuffle step happens through a group. So it takes a logical break and it combines this information and it applies a reduce function. So the reduce function is sum function, which is take a count and sum it up. So Peter is present 2 times. Now 1 plus 1 equal to 2. So like that, and then again you perform the reduce step and you come up with final result, which is Peter is present 4 times, picked is present 4 times, papers is present 4 times, like this, so on and so forth. So this is how the MapReduce works. But this is not universally applicable for different kinds of tasks. So it's very important to make it scalable, universally applicable to other scenarios. Without that, it cannot be taken up as a framework to do analysis. That's why this Apache Mahout, it was, I think you will not be able to see this logo on the web. It is already deprecated. Maybe you can get on the older some of the posts somebody has updated. You can check this. So this became deprecated in the year 2017 or 18. Yeah. So this is Apache Mahout. It's an open source framework that is primarily used for creating scalable machine learning algorithms. Initially, they were supporting recommendation, classification, and clustering. Then it became redundant. And this is a screenshot which I kept, and it is from, I think, 2018, 17 or 18. I took this screenshot quite long back. And they deprecated those logistic regression, naive-based, hidden Markov models, k-means clustering. So all those things are deprecated. And why? Because not only it is not MapReduce compatible, the results were also not promising enough. That's why they deprecated those functions. They only retained the recommendation part of it, which is compatible with the MapReduce. Okay, all others. Now here comes the challenge. Your data you have stored in Hadoop. However, you are not able to perform analysis on top of it. You are not able to run models on top of it. Then what should we do? That's why Spark enters into the big data world. So when Spark enters, these were some of the tools. So there is Apache HBase, Majus, Cassandra. Cassandra is a similar to MongoDB. It's a NoSQL database. Apache HBase, again, it is a structured tabular structure. Majus, it helps in processing the data on top of a Hadoop. And then came Spark. Before Spark enters to the Hadoop ecosystem, these tools were there before. Okay. Apache Spark, the main advantage of it is they provide distributed computing, which is replacing manual way of creating MapReduce programs. It internally uses the MapReduce only, but it is designed in such a way that even if it is using MapReduce, the user is not getting to know or feeling the pain of writing those MapReduce programs. Okay, that's why the advantage is the Spark. It runs on top of Hadoop, Majus database, standalone, like standalone Hadoop or standalone Majus, or it is in cloud. It can access other sources Like this is again a screenshot taken in 2018. Now it supports huge number of other databases. You can write or you can run this on MongoDB, Cassandra, BigQueries, other tables also. It supports right now. So Spark suddenly become very, very popular in a big data world. Now Spark has core 4 modules. It has a Spark SQL module. Spark SQL module helps you in writing SQL queries. Okay, I'll slightly go back to the previous world of MapReduce program and distributed query. Okay, so what happens here? You have a distributed storage. Now you have to write queries to get the data, right? If I have to write queries on HDFS, what should be the language? Language is only MapReduce. But if I have to write a SQL query, what should I have to do? What do I do? If I have to write a SQL query, then it has to be in a Hive query language, HIV, Hive. Hive as the query language that I have to use. Now, organizations over the years, they have written many SQL queries, which is running various applications. Legacy systems, various legacy systems in various organizations, they have like thousands of SQL queries they wrote over the years. Different teams, they have a bunch of SQL queries that they run every day. Now, if I'm in a big data world, because my volume of data has grown over the years to a larger size, and my SQL queries are not compatible. Because can I write my SQL queries on top of a big data using Spark? Now Spark makes it possible. So how it makes it possible? You can take up your existing SQL queries, run the Spark SQL module. Within this, you pass the existing SQL queries. You don't have to change your queries. You can use the same query here, and you should be able to leverage the distributed computing power of Spark, so that even if you migrate from MySQL database to a Hadoop database, your same SQL query would work. Clear? Yes. Okay. Next is Spark streaming. For live streaming data, you have to process it in lightning fast speed. So to make that happen, Spark streaming is a separate module or core module of Apache Spark. Then comes the machine learning. If you have to execute ML algorithms like linear regression, logistic regression, decision tree, gradient boosting, or various other models, naive Bayes or some other models, you can leverage the existing ML live functionality from Spark and run those algorithms on huge amounts of data. The humongous amount of data is stored in Hadoop. Okay. And finally, there is a graphics functionality or graphics core library. What does this mean? It means like social media data. For example, YouTube, Facebook, Twitter, or any kind of social media data. There are, let's take millions of users, but all millions of users are not connected with each other, right? Some people, they will be connected with maximum 100 people, 1,000 people, 20,000 people, or maybe 1 lakh people. Not possible that each individual is connected to all million people, right? If I put a structured data, users, user 1, and here user 1 to 1 million user on the columns. Now, if this user is connected to user 1, 7, and 9, then it will have 1, else it is 0. So the first row itself will get updated for all 1 million users. Out of 1 million, maybe if this person, first row, this person is connected with 2 people, only 2 people will have value 1. Rest 1 million minus 2 columns will have a value 0, right? So like this, if I collect a million cross million metrics, I'm taking a small scale scenario, million cross million metrics. If I'm just taking the social media data, right? There is a high sparsity in the data. Like few people will always be connected to few other people. Not everyone is connected with everyone. In that scenario, only you will get once in all the cells of the matrix. If everyone is connected with everyone, right? So, which is practically impossible. Very less people will be connected to a few set of people. So there is a high sparsity in the data. If you store the data in a structured tabular format, then the data storage you would need is huge, processing would be huge, and running queries will also be huge. So to save this sparsity and reduce it to a condensed form, graphics came into picture. So you have to store the data in a graphical way. This person is connected to 5, only 5 nodes, you just establish the edges. There are nodes, edges. Using the edges, you connect to the nodes. And the graphics supports graph queries. You can write on top of the graph database. So basically all social media data, you can represent it as a network, as a graph structure, so that you can avoid storing it as a large sparse tables, and you can perform efficiently various queries and run it on top of it. Is it clear? Any questions? Anything you would like me to repeat, or it's clear? Very good. Cool. So Spark is for lightning fast cluster computing. Now, these things we have already discussed before, the core concepts associated with it. Now, this is how the architecture is. So there is a client submits a Spark application. Now what happens after that? Now this driver sits in a master node. The master computer, which is a cluster manager, it's a 3-node cluster. The Spark application is connecting those 2 worker computers to the master computer. There is an executor. The driver sits here with the master computer, right? The driver can be connected directly to the workers as well. Can be connected to the directly to the workers as well. However, the master is the one who allocates the memory, the containers, executors, and oversees the executions and gets back the results from the workers. So the master and the worker is having direct connections. The connections with the drivers is just for listening. Execution of the processes that happens through master and worker. Yeah. Okay. So Spark uses Hadoop in 2 ways. One in storage, second one is in processing. Now, Spark has its own cluster management computation, and it uses Hadoop for storage purposes.
కనెక్టివిటీ ఉంటుంది.
Hello. These things we have already discussed, those tools and how to use the built-in APIs from various other tools. Yeah. Now this deployment for big data.
Pradeepta, sorry to interrupt.
Yep.
Can you go back to, I think, the previous, yeah, this one. Okay, so this says Spark uses Hadoop in two ways. One is storage and second is processing.
Processing.
And the second one says since Spark has its own cluster management computation, it uses Hadoop only for the storage purpose. I mean, which one are we supposed to follow,
Right.
basically?
Right. I'll go back to again this graph. So here Hadoop has one YARN framework. So yet another resource negotiator framework. This sits within Hadoop. Okay. Spark also has its own YARN. Okay. So which means if Spark one works on top of Hadoop, there are two YARN processes. One is for Hadoop, one is for Spark. So two yet another resource negotiators are there. Basically, two YARN processes are there. When you say cluster management, YARN is responsible for cluster management. Okay. The cluster management, it takes care of the computations. So this cluster management computation, you can leverage Hadoop's YARN system, or you can use Spark's YARN system. So you have two options. Okay. Now, Spark can use Hadoop in two ways. It's not mandatory. It uses Hadoop in two ways. One simple storage, one using YARN, Hadoop's YARN for processing the computation needs and doing cluster management. Right? Since Spark has its own cluster management computation, it uses Hadoop for storage only, which means there are two ways. This talks about two ways. One, either use Hadoop for storage only and use Spark's YARN process, or use Hadoop's storage and YARN process. Both. Simpler would be using Spark's own YARN process. So in that case, you will be only using Hadoop for storage.
Right. Okay. So that's the suggested approach where we use the yarn of Spark, right?
Yes. Yes.
Thanks.
Okay. So these is features of Spark, which we have already discussed. Now, this is the deployment process. Now, if I'm using standalone Spark and HDFS is only for storage. Now here what I'm using is I'm using Spark's own YARN process. Okay, cluster management, Spark's own cluster management, which means HDFS is only storage for me. Here. Now, if I'm going to the second way of deployment, okay, this is V1, which is deprecated now. It is no more in the scene right now, which means this older way of implementation, right, where it is like standalone integrated MapReduce program, SIMR. Now this MapReduce is from Hadoop only, which manages the clusters, which manages the processes, and HDFS is for storage. This is one way where we are removing the YARN process of Spark. We are only keeping Spark for computations. We are using MapReduce framework from Hadoop, but this has certain issues, so it is no more valid now. Today we are using Hadoop 2.0 plus. Now in 2.0 plus, YARN concept came into picture first time. YARN was not there here. Spark has its own YARN, but this older way of deployment, it's no more existing, it's deprecated. We have only those two scenarios today. Now here in this case, either you use Hadoop as a storage and use YARN processing from Hadoop itself. If this is the scenario, then you are not using Spark's YARN process. You are using Spark only for computation. Now, when I say here Spark uses Hadoop in two ways, this is the appropriate graph. So Spark uses Hadoop for storage, for processing and cluster computation management. So there are two options here. Either you use measures to do that or you use YARN to do that. So instead of introducing another tool, you remove this tool and keep only Hadoop yarn. So Spark now uses Hadoop for storage, Hadoop for yarn cluster management. Okay. Now in this world, this is Spark's own cluster management tool. Yarn is there in between. Hadoop is only used for storage, which is a standalone mode. Now this standalone mode becomes very popular and it's in practice. People are extending this to cluster modes from standalone mode. Clear now?
What do you mean extending this? Like this is the
This
architecture.
is single machine. Yeah, this is single machine. Now we can extend it to clusters.
Multiple replicas of it.
Yeah, different replicas.
And which one is better approach? I mean, the first one or the second one?
First one and second one. I think first one is better. Second one, I think you need additional processing to manage the yarn from Hadoop. You need additional tools, you need visibility, you need dashboards to showcase the results. So bit difficult. So we should go ahead with the yarn should be from Spark's own yarn. That's the second. Since Spark has its own cluster management computation, it uses Hadoop only for storage purpose. This is a good combination.
Okay.
Okay. So this is some text around this. Standalone. This is Spark and MapReduce. This is something which we have already discussed. Apache Core, Spark. Okay.
So this is Pulkeshu. Sorry to interrupt you. Okay, someone has joined in race support. May I know the name? Who's using race support ID?
Pulkeshu, you're asking me?
Yes. Yeah. Well, I think one of the participant is using race support ID. Can you just tell me your name?
Pulikishi, I think this is the one which is there in the class, right?
Oh, okay, Jyoti. Fine. Got it. Fine, Jyoti. Thanks. Sorry, sir. Sorry to interrupt you, sir.
No problem. Okay. Now, Apache Spark, again, it's a in-memory computational framework. When I say in-memory, it reads the data directly and stores it in memory and processes. That's why it provides lightning fast computation speed. Okay. So whatever data we are ingesting, the data gets converted to something called RDD, resilient distributed data. Resilient distributed data set. So the basic data structure in Spark is called RDD. So when you do import, like typically in Python, when we import a data set, it becomes a data frame, right? Similar kind of concept is also there, which came little later. In Spark first version itself, the first data type was RDD, resilient distributed data set, meaning once it is created, once it is available, it cannot be updated, modified. You can only just do transformations. Okay. So it is fault tolerant. Something breaks, you can still get back the original RDD, upload it, and do transformations. If you want to use the RDD, you can perform transformations. Transformations could be actions like filtering, aggregations, multiple filtering, joins, everything you can perform. So when you upload data sets of different types, TXT, Excel, CSV, database files, SQL, PostgreSQL, HDFS, whichever data you are uploading, it first gets converted to RDD. Okay. Now this RDD holds the object and it stores it in the memory. The RDD is again, it's distributed. Distributed means small chunks of RDD would be created, and you can define the replicas also. How many replicas? So replicas, the purpose of replica is getting back the data quicker. That's why you have to, you can increase the replica. You can make 2, 3, 5. But the more replica you will create, the faster you can retrieve the objects and return the results. However, the number of replicas is subject to the memory allocated to the machine also. Okay, so performance versus allocations. You need faster processing, store more replicas. You can process faster, right? And if your parent object size is too big, then you can split it into multiple chunks. That also you can define. So chunk size is something which you can use to split the RDDs into smaller chunks. Okay, so these are a couple of, and we'll get to that, how RDD looks like and what are the functions we can apply. We'll see that in our hands-on sessions. ML library, again, this is to perform machine learning on RDD. Graphics, we already know. And typically how the Spark program runs. So this is again your Scala program here. This is a user program. So first you create a Spark context and initialize the SC, which is a Spark context, establish it. Then you read a table. Now suppose we are reading a table from Cassandra. So SC dot Cassandra table, and you define what table you want to read. Now once you read what you want to do, I want to apply map function to do something. I want to do a filter function to do something. I want to do a group by on key by and perform something. Reduce by key by, and I can write a function. Let's take aggregations like average, sum, count, etc. I can specify here. And then once you get the result, then cast the result. Now this entire activities is stored as RDD. Right? Now this program goes to the driver. Now the driver, what it does, it creates the RDD graph. How this RDD should be processed. You read the table, apply map function, do a filter function, do a key by, reduce by, and cast. So this RDD graph, it creates a DAG scheduler, directed acyclic graph scheduler. This DAG basically logical split of tasks and steps it defines from the program. Then it triggers what tasks need to be scheduled. Then the scheduler backend takes the task scheduled here and sent it to cluster manager. Now this cluster manager is the Spark's own Yarn program. Now this checks how many executors are there, how many executors and worker nodes are there. So each worker node can have single executor, multiple executors. It checks and it checks how many tasks are there. Then it assigns the task. The executor runs the threads and the execution happens on the blocks. Block is nothing but the distributed chunk of RDD which is getting stored, the data storage. Each block is a logical partition of the data, and with replications, it stores multiple copies of the same data elements into the blocks. There is a block manager which manages small blocks which stays over here. And using these blocks, the threads perform activities on the blocks to read the data and perform the activities like any kind of reduce by or key by activities, returns the result to the cluster. Cluster manager again returns the result to the driver program and it shows the final output. That's how the Spark job execution happens. Any questions on this?
Sir, that block manager, does it behave like a cache? When you said that it will store some data, right?
No.
Yeah.
Cache works outside of it.
Okay.
First, it has to perform. See, block manager holds the blocks.
Okay.
And those are nothing but the blocks, or logical blocks of the data with replications.
Okay, okay. So those are the actual data that is being processed by the threads.
Yeah.
Okay, sir. Okay, fine.
Okay. Now we can get into a little bit more about understanding the Spark side of things. So these are my RDD objects when I upload a data. Like suppose here there are two RDDs. I'm doing just join. RDD1 join, RDD2, and the join, after join you want to perform some group by and do some filtering. Now once you create this workflow, it builds a DAG. Now this DAG, what it does, it splits the graph into stages of the task. Each stage performs some task and it submits each stage as ready to the next. Now these tasks are going through the task scheduler. Now this cluster manager, it takes one task, assigns a task to a worker. Assuming a single worker, it first assigns the task, executes the task, store and serve the blocks, takes up another task. So launches the task via cluster manager and retries if failed, or any kind of staggering tasks also it waits, right? And sequentially it processes all the tasks. Now this DAG scheduler, it is actually agnostic to the operators, whatever maybe the operators are there. The task scheduler, it doesn't know about the stages of a task. The tasks are already being scheduled and it task scheduler just manages the tasks using cluster manager. Okay. So if a stage is failed, it just returns a failed status. That's it. Task is this and it's in failed status. Okay. Now some definitions about RDD, which is called resilient because RDDs are immutable, which means it cannot be modified once it is created. And why it is distributed? Resilient means immutable. Distributed means because it is distributed across the cluster. Dataset because it holds the data. That's why RDD stands for resilient distributed data. Immutable definition cannot be modified once created, but only you can apply transformations on top of it, right? So RDDs can contain any type of data, like it can hold Python objects, it can hold Java objects, it can hold Scala or R objects, including user-defined UDF functions also, or Pandas UDF functions also it can contain. So each data set in RDD is divided into logical partitions, and those partitions are distributed across different worker nodes in a cluster. Clear? If any questions, let me know.
It is clear, sir. Thank you.
Okay. Now let's go back to, so this is how this is the parent RDD. This is the parent RDD. And then it is distributed across multiple partitions. The objective of distributing across multiple partitions is to get back the results quicker. These are basically partitions. And you can evaluate the task, perform one task per partition, and then combine the results. So RDDs are divided into smaller chunks, which are called partitions. And when you execute some action, a task is launched per partition. It means the more the number of partitions, the more parallelism you are going to achieve. The larger the size of RDD, the more should be the number of partitions. That's why you can achieve maximum parallelism in a distributed computing system. Clear?
Yes, sir.
So Spark automatically decides the number of partitions that an RDD has to be divided into. However, you can specify the number of partitions too. You can say 20 partitions, 30 partitions, 100 partitions you can do, right? And these partitions are basically distributed across all the nodes in the network. Okay. Now here comes a little bit more concept about the RDD. Why RDD based solution is the best solution? Okay. Because see, RDD is in memory. That's why it is fast. So data sharing is slow in MapReduce due to replication, which means MapReduce is always an input-output heavy operation. So there are a lot more to and fro call happens from file system to processing layer. It reads certain data, does the mapping, again reducing, then storing it back. So a lot of input to output disk operations happens. MapReduce. That is why 80% of the time MapReduce takes it is input-output reading. So to avoid this input-output reading, your data, if it resides in the memory, you don't have to write and read from disk. So most of the Hadoop applications, they spend more than 90% of the time using Hadoop read-write HDFS-based operations. That is why Spark came into picture, so that RDD, once it is created, it is stored in memory for computation. It stores the state of the memory as an object across the jobs. And the object is also shareable between the jobs. So data sharing in memory is almost like 10 to 100 times faster. Because you are not reading from a network, your data is not getting transferred over the network from one storage system to the computation system. So you are getting rid of this 90% of the processing time, and you are focusing more on the computation part instead of input-output reading or read-write operations. That is why Spark is faster than any other computing framework and MapReduce. Clear?
But still the data should be stored back to the Hadoop, right? After the MapReduce, the final output.
You can write it anyways, but that comes at a very later stage. You don't really need to store that after every function. You do a filter, you want to store it back to the database. No. You perform the series of actions. Final outcome, if you want to store it in the database, you do there, like you can just do like RDF cache. You can store it in cache memory. RDF, write it to a database, one time writing to the database.
So we're just using Hadoop at the last stage, right? Like once
Yeah.
every operation is done from at the Spark level, finally we are writing it to this database.
Yes. Okay. Fine. This MapReduce union distinction. Okay. Now this is a concept of the transformations. Now you want to apply some mapping functions, filter functions. You are doing something here on the RDD. Since it is immutable, you cannot modify this RDD. You are creating a new RDD, which is a replica of this after applying these transformations. So you perform some actions here. Sorry, not actions. I'm sorry to use that word because action is reserved for something else. So transformations are map, filter, key by, group by, or any kind of like other reduce functions. Sorry, not reduce. Reduce would be action. So transformation functions. So entire set of functions in Spark can be classified into two groups: transformations and actions. Transformations are changing the state of the data after applying certain filters, mappers, group by, etc. This creates a new RDD. Now on top of it, you can apply another set of transformations, create another RDD, and so on and so forth. If you no more use it, then delete it and archive or purge the RDD. If you are using it, keep it as it is and use the state of this RDD for further computations. Okay. Actions are nothing but reduce step or storing it to the save as text file, save as text file in the HDFS system. These are actions. Actions can be triggering an algorithm, triggering an ML model, storing the results to file system, storing the results to databases, storing the results to HDFS system, applying reduce functions. These are going to be the actions. Okay. The actions sometimes take a little bit more time because it is writing to database systems or maybe storage systems. The transformations are quite fast. Okay. And the actions sometimes take some time depending on the situations, size of data, size of kind of actions that you want to perform, etc. Okay.
What would be the example for transformation, like a map?
Yeah, so transformation example is this one. You read a table, then apply map function, then did filtering, then do a key by, then reduce it by key by, and you are performing cache. So 1, 2, 3, 4, 5. There are 5 transformations you are doing. Finally, when you are doing cache, this is an action you are performing because you want to cache the RDD. So there are 5 transformations and 1 action.
Basically, transformation is like means what? Like in a sense, like we're changing the data, or like
you are not changing the data. You are actually right. So in Python, when you run the merge or unfiltering or drop duplicates, some of the functions you are applying in a Python object also. Imagine this is a Python object. Okay.
Okay.
Now on this Python object, you did some sorting, you did some like ordering of the data frame. Now finally, if you are doing in place equal to true, then the entire Python object is getting modified, right?
Yeah.
Right. Now that is not allowed here. You apply filter, you apply whatever logic, ordering, sorting, etc. If you want to you want to update the original RDD, you cannot do that because it is immutable. You should not change the original state of the data. So you can create a new RDD out of it. Python, when you apply some transformations like a map function or a filter function or a group by or order by or sorting, you are doing in Python. When you print it, post applying the transformations, when you're printing, you are seeing a data frame in Jupyter Notebook, right? In Python. But that is just a display. That is not stored anywhere. If you want to store it, there are 2 ways. Either you update the parent object by using in place equal to true, or you write it and assign it to new data frame, call it new DF, new data frame, or data frame 1, data frame 2, etc. Right? So when you are storing it back to a new data frame, that is equivalent to this. You are creating a new RDD. Now, Spark is not allowed. In place equal to true is not allowed because it wants to retain the original state of the data. You can ask me why? Because you are doing some activities here, but later on you may want to use this RDD to do something else. This is your single source of truth. If you are dropping it, you may have to read another terabytes of data to create one RDD, because unnecessarily you will be again reading the data from file system. Right? So if you bring RDD once and do a cache, or maybe do a like purge or persist it in the Spark computation framework, you don't have to read multiple times a RDD. Imagine every day somebody has to read a data frame to do some activities. In Jupyter Notebook, it is easy. We are just doing simple pd.read_csv. Okay, read it and do it. Every day we don't mind running the same script. Now, if the data is in GB and you are running the same Python script, probably you have to wait 1 hour every day because the data need to be uploaded, some transformations need to happen, then only it is usable to you. In order to avoid this 1 hour delay, what essentially you can do is read it once, persist it in the environment. It will occupy some storage in the memory of the Spark cluster. Let it be there. Every day you don't have to read this because, like by definition, it's a big data. And reading the big data takes its own time. So you don't have to, why do you want to read it every day? You read it once, keep it there. You want to use it, apply transformations. This one, you want to delete, you delete it. Any transformations, you can delete. But original RDD, let's keep it there. Clear?
Yeah, it's clear. So maybe new RTD we can use it to for the just for the insights and delete later, right? Yeah. Keep the original one.
Yeah. Okay. Now caching. So cache strategy is pretty good. RDD cache. And if you keep it in the cache, you can even serve it faster. So partitions you can cache, parent RDD you can cache, and there are n number of nodes you can clear, and each cached version would be supporting each of the partitions and nodes. Right? So that is for processing it faster. So you can cache one RDD in memory by calling rdd.cache. When you cache an RDD, its partitions are loaded into the memory as well, memory of the nodes that it holds. So caching improves the performance of your entire application. Now, caching stores the computed results of the RDD in memory and thereby eliminating the need to recompute it every time. Imagine your transformations you have to do here. Now you cache this new RDD so that you don't have to even apply this. Your parent RDD persists in the memory. New RDD you cache it so that you don't have to compute it every time you load the script. Okay. Now, implementing big data, there are two major tools, Python and R. Python, you can use Spark plus Python, it becomes PySpark. Spark plus R, it becomes Spark R. These are two ways. And if you look at the usages, it is quite clear. Statistical operations, graphs, plots, etc. you want to create on big data, use R. That doesn't mean you cannot use Spark to do that. You can use, but mostly for statistics heavy operations on a big data, you can use Spark plus R. Okay. Why? Spark brings the scalability, fast processing. R brings in the statistics and plots, graphs and charts. Okay. So that is why Spark and R helps. However, R can be replaced with Python. Now Python brings additional functionality of connecting to other packages. Python brings in additional functionalities of extending it to orchestration layers, extending it to DevOps processes, extending it to MLOps, extending it to supporting other product applications and features. There are so many extended benefits of using Python. R, it is specific to a project. Python, it is extended towards applications, products, or any kind of AI-based operations. Clear? And that's all. So, any questions on this? This is concept of RDD and Spark and how the entire whole system works. So then we'll proceed with the hands-on part of it, seeing actually how it works. Any questions? No questions? So we'll get into a little bit more technicalities. Next. Okay, before getting into a little bit more technicalities, I think we should do the environment setup and we should do a little bit hands-on. Okay. Then only we'll get into the technicalities of it. This one we'll do later. Okay, cool. Okay. Can you go to downloads? See, there are two ways to set it up. Okay. If you are comfortable with local setup, you can download and install it locally. You can perform all those computations locally. You want to do this installation on cloud, it is quite easy because you can get rid of the whole installation process there because it's working there already. And I think the system setup is done for you. So if you are on a cloud environment like AWS or GCP or Azure, or maybe Databricks. Databricks is another platform where it supports the Spark based computations. Okay, so if you are on those kind of platforms and you have access to, you don't have to do this installation steps. Clear? And if you want to set it up locally on your machine, then you have to follow this. Do you have to do local installation? Let me know.
Would our laptop support this the
Yeah,
volume of data and all, right?
yeah, why not?
Sure, then.
So Pradeepta, I mean, how do we do it on cloud? I mean, if we do not have access to Microsoft Azure and also AWS.
Hmm. Okay, so you need access, right? Without access, how can you do it on cloud?
Right. So is there a way, I mean, if I'm not sure, I mean, will Race will be providing it access because setting this up on our system is like, the resources of our system will also be used?
See, single resource, single computer setup you can do. You don't really need huge computations, or you can upload a smaller, like a 2x2, 4x4 matrix, you can upload and do a Spark computation, right? Idea here is to learn the Spark way of writing programs. How to make it scalable? Definitely in future when you work on like different client environments or with different organizations, you will have access to AWS, Azure, and GCP, where you can try this.
Right. So in that case, I think the only option is to set it up on our system.
Right, that is one. There is one more option I can tell you that is called using Databricks Cloud Edition, which is public edition, uh, which is called Cloud Community dot Databricks. So go to community.cloud.databricks.com, sign up. Let's do the setup right now. Okay, I'll just send this in the chat window. Please click on this link. You will click on sign up because I have already signed up. So click on sign up, fill the form, generate your password. Once you get the password, then use the login ID and password and sign in. Okay. It is still an evaluation version. You can see on my machine. Here using Databricks Community Edition upgrade for unlimited clusters and collaboration features. I don't want to upgrade now. I'll do it later. So once you are entering to this, there are two tracks you will be able to see. Data science and engineering track, and there is a statistical or modeling machine learning task. There are two different tracks you can see. Okay. Now in this, you can see the roles here: machine learning track, data science and engineering track. So this is a data engineering track. This is a machine learning track.
Pradeepta, can you please hold on for some time? I mean, there are cloud provider options which is coming, and what do we need to select?
AWS.
AWS, okay.
Because this runs on top of AWS. Done. So first you do the sign up and get your account ready. Okay. Then other things we'll do later. So everyone should be able to log in to community.cloud.databricks.com and should be able to open an account, at least should be able to log in. Once you log in, then the next steps I will cover it maybe after the lunch break. So it's almost going to be 1. So we'll be back by 2.
Sir, before that, should we have that particular Spark tool installed in our system?
Not required. Not required.
Okay. Because I just downloaded that and I was trying to install on my Windows. It is not.
That I will tell you later.
Okay,
So,
sir. Fine. We'll wait for your call then.
Yeah. So this one has certain issues. I'll tell you that how to do a troubleshooting.
Okay,
If
sir.
you're going this way, if you are going this download Spark, so you have to click on this to download Spark, right?
Okay. Yeah, I did that. And I have that package, on the system.
Yes. You have to extract it.
Yes, I did that, sir.
After extraction, there is a set of things we have to do. Okay, and if you are on a Mac or Ubuntu, it will not have an issue. But if you are on the Windows, it has certain errors or issues that we have to troubleshoot.
Okay, sir. We'll do that after lunch then.
We do that after lunch. So that's why I wanted to first set up this here using a cloud access, which is easier for us because we are not using heavy data to upload over here.
Okay.
We are using simple data. So yeah, let's do that.
Sure, sir. Thank you.
Okay. Sure.
Okay. Thank you, sir. Thank you.
Okay. And before two, please make sure that you have access to community.cloud.databricks.com. You're able to open your account using your credentials. You should be able to log in. Right after that, what to do? We'll cover it. Okay.
Okay, sir.
Fine. Thank you. So we'll take a break now.